Hello, this video is going to serve as a very brief introduction to AC circuits. Up to now, we've learned about DC circuits or direct current circuits. All of our circuit elements in our circuits were connected to a battery. So a battery provides DC current. This means that the current is only flowing in one direction. If this is the positive terminal of the battery here, this is the negative terminal. We learned in previous videos that the current always flowed away from the positive terminal. So the current would just go clockwise in this circuit. So now we're ready to look at AC circuits. AC stands for alternating current. What this means is that both the voltage and the current are going to oscillate back and forth. At one moment, the current is going to go one way, and then the next moment, the current is going to go this way. It's going to keep going back and forth, and this is a symbol that we can use to represent alternating current in our circuit. These devices over here are resistor, inductor, and capacitor, and we'll see in the following videos how these devices can be connected in our circuits and what are going to be the advantages and applications of these types of alternating current circuits. So an AC circuit is simply a circuit that is going to have an AC source and whatever elements that you want to put. We'll start off with just a resistor and then add capacitors and inductors. You can use a sine function to represent AC current and voltage. So this sine function is the same thing that we learned about generators, that generators generate an oscillating function, an alternating voltage. So what this sine function shows is that at one moment you've got no voltage. You could have the same function for current, right? You can pretend this has current instead of voltage. At one moment you have no voltage, and then it increases until its maximum value V0, and then it starts decreasing back to zero, and then it becomes negative, right? So what does that mean? You can just pretend that you had a battery in your circuit, and let's consider this a positive voltage, and then after it reduces back to zero, it's as though now the battery's facing the other way, right? So first the current's going one way, and then the current's going the other way, and it keeps alternating back and forth as the sine function shows. So I'm using the lowercase here to represent the instantaneous voltage and current, so the voltage and current at a specific time. Time is right here, so you can plug in whatever time that you want and get your voltage at that time. V0 and I0 are the maximum voltage and current, and omega is the angular frequency that we learned about in the previous video with generators. That gives you the number of cycles per second, but as an angle. So this picture shows here that the period of this wave goes up to here. The period is the time for that one cycle. The frequency F would be the number of cycles per second. So if this period here was 2 seconds, well, how many cycles are there per second? In 1 second, this would be 1 second, there would only be half of a cycle, so the frequency would be 1/2 hertz. And then the angular frequency is 2 pi f, so it would be 2 pi times 1/2, or pi radians per second. So when you use this equation, make sure that your calculator is in radian mode. So we're going to see applications and advantages of AC circuits in the following videos. For now, the last thing I'd like to say is that AC voltage is what our appliances operate on. So you may have noticed in your light bulbs or other appliances that it says 120 volts. So that's the voltage that we're getting when we're plugging in our appliances and our outlets. We're getting a voltage that is oscillating back and forth. The frequency of that voltage and current is actually 60 hertz. The maximum voltage is 170 volts. So 120 is actually the RMS voltage, and we're going to learn what that means in the next video.